Question is, object A is kept fixed at a point whose x is 3 meter and y is 1.25 meter on a plank P raised above the ground. At time t is equal to 0, the plank start moving along the positive x direction with an acceleration of 1.5 meter per second square. At the same instant, a stone is projected from origin with the velocity of u as in figure. So this is the basic figure. So we have a plank which is a distance of 3 meter and 1.25 meter at height, and it has a stone A. So it starts moving with the acceleration 1.5 meter per second square, and the same moment a stone is projected from the origin with the velocity u. A stationary person on the ground observes the stone hitting the object during its downward motion at an angle of 45 degrees to the horizontal. All the motion is in xy plane. Find velocity vector, initial velocity vector u, and the time after which the stone hits the object, taking g as 10 meter per. So in the question it is given that there is a plank and there is object, and stone with the initial velocity u, let us suppose at a angle of theta with the horizontal, is thrown such that it hits the object. This distance is given as 3 and its height is given as 1.5. So it means we can say that x coordinate of initial velocity of the stone can be given as u cos of theta, y can be given as u sine of theta, acceleration in x direction will be 0 and in y direction will be equal to minus g. So first of all we are going to deal with the stone. So we know that the height that will be taken by the stone is 1.5 meter, this much. So we can say that the displacement in y direction is 1.5 meter. So we use the formula s of y is equal to uyt plus 1/2 a by t square, and it is also given that g should be equal to 10. So we can write this as 1.5 is equal to u of y is u sin theta multiplied by t minus 1/2 g of y t square. This can be written as u sin theta multiplied by t is equal to 1.5 plus, you can substitute here value as 10, so this will be plus 5 t square. Sorry, it is given as 1.25, my mistake, 1.25, and this will be 1.25. So in horizontal direction, if you say in this was vertical and this is horizontal, in time t the distance traveled, let us suppose it is given as s of x, the horizontal distance traveled by the stone. This will be equal to u of x multiplied by t, and ux is given as u cos of theta, so this will be u cos of theta multiplied by t. Now we concentrate on the object. object A. Now object A is already at a distance of 3 meters from the origin. So we can say that displacement of the object in time t. Displacement of object A in time t will be equal to initial displacement of A plus displacement due to acceleration. So initial displacement is 3, and let us call the displacement due to acceleration as SA. So initially the object was at rest, so we can say that initial velocity of object is 0, and acceleration of the object is A of A, which is given as 1.5 meter per second square. So we can find out the distance SA will be equal to UAT plus 1/2 AT square. So this will be 0. So we are left with SA is equal to 1/2 multiplied by 1.5 T square. So SA will be equal to 0.75 T square. So we can say that displacement of the object in time t will be now given by 3 plus 0.75 T square. Next, we are going to consider now what will happen since the stone hits the object. Since stone hits the object A, we can say that u cos of theta multiplied by t will be equal to 3 plus 0.75 T square. The horizontal distance should be same. And we also know that the stone hits the object when it is coming in the downward direction. So we can say that, let us suppose it's here is object. So if we divide it into two parts, and angle is given as 45 degree. So this will be our Vx and this will be Vy. So as angle is 45 degree, we can say that horizontal component of the velocity, that is Vx, it will be equal to vertical component of the velocity, that is Vy. So let us find out the horizontal component. So we can say that horizontal component Vx is equal to Ux plus Axt, and know that acceleration in x direction of stone is 0. So we know that Ax is equal to 0. We can say that Vx is equal to Ux. Next we find out vertical component. You can say that Vy is equal to Uy plus Ay t. So Vy is equal to Uy minus Ay is given as minus g, so this will be minus g. Next we find out the tangent of minus 45 will be equal to Vy by Vx. We put the values, we get Vy minus gt divided by Ux is equal to minus 1. And we can say that Ux is equal to minus y minus gt. If you put the coordinates, we get u cos of theta is equal to minus u sine of theta and plus gt. This can be further written as u cos of theta gt minus u sine of theta. So multiplying this entire equation by t, we get u cos of theta multiplied by t is gt square minus u sine of theta into t. Now we know u cos of theta multiplied by t is this value. We substitute it here, we get 3 plus 0.75 t square is equal to gt square minus, and we already found out what will be the value of u sine theta multiplied by t. This is the value of u sine theta multiplied by t, that is equal to 1.25 plus 5t square. We are going to get 1.25 plus 5t square. This is 3. Okay. So we can further solve it, and we are going to get this as 4.25. 4.25 is equal to 4.25 t square, or we can say that t is equal to 1 second. So we already found out what is the value of t, and next we are going to use this value of t to find out the both the components. So we are going to find out u sine of theta multiplied by t, which is given as 1.25 plus 5 t square. So we put the value of t as 1, this is 1.5, and this will equal to u sine theta is equal to 6.25. Similarly, u cos of theta multiplied by t is given as 3 plus 0.75 t square, or we can say that u cos of theta is equal to 3 plus 0.75, and this will equal to 3.75. So it means we got the x component, and this is our y component. So velocity vector of the stone will be nothing but uxi, unit vector rather, and uy, unit vector j. This will be equal to, we put the values, ux is 3.75 unit vector I plus u of y is 6.25 unit vector j. This will be our initial velocity vector of the stone. Thank you.